And what would be really great if you guys, some of you guys have Visual Studio installed, if you could try running the application. I think it would make the experience like a lot more enjoyable because you can tweak it. At least last meetup with Trafford, I really enjoyed being able to do things instead of just listening, because I like to try things out. To install things, basically all you need is you need to go to this tiny URL, which will take you to a GitHub page, and you can either clone that. Hi, there. You can clone that, or you can just download the release with zip file, which will be a solution written in F# with WebSharper installed via NuGet. So hopefully it will just work. Let me know if it doesn't. We can troubleshoot.
Okay. Sure.
Well, by all means, even if you don't plan to play with it, or you don't have F# doesn't work for you, if you go to the URL, so the code is there, so you can look at it in the code.
Did you hang out with the you streaming?
I thought it was streaming.
Correct?
Can you help me check?
Yes.
I gotta check.
We just started.
There's a little URL with a GitHub project. It might just work for you. It might not. You will troubleshoot, but yeah, that's.
How's the traffic? Sorry.
No, just walk from there. It's easier.
Right.
FH, yes, I guess. Yeah.
So Ricardo, do we have news on the broadcast working or not? Or should push something here? It looks like it's recording my voice from the laptop. Maybe I should not be running around. I should sit here and talk to the tree.
I should use the F# beta group, I guess.
Yeah.
That's the password of that.
Which basically they, if you ask F# to, it will save the code uninterpreted in the DLL when you compile the DLL. So WebSharper does take that and transpiles it to JavaScript, does a few optimizations. It implements client-server interop, and it has some combinators for making websites. Tonight we're looking at a very simple use. We're not really making a website, although this is a website. We're just making an animation and using canvas. Welcome.
So there was bad traffic, huh?
All the best in the truck.
Just for the record, has anyone managed to get the code on their machine? Not really. Nah. What issues are there?
Anybody run the code yet?
To compile and run in the airplane machine?
And then I start code that is missing telefactory.
Yeah, it doesn't build.
No.
There's
It's very likely there's something that I'm just missing though.
there is a NuGet restore, and there's unfortunately a bug in NuGet that sometimes makes you restart Visual Studio and then it works on the second time. So if that's the case, just try restarting Visual Studio and opening the same project. But if that doesn't work, then it doesn't work. Oh, that's a pity if you don't get it to work.
So you have to have a telefactory installed?
Huh?
You have to have it installed. And can you show where you do the NuGet restore?
How do we do NuGet restore?
Yeah.
Right click on this.
Actually, on this machine, I just opened the solution. I downloaded the zip from the GitHub.
Yeah,
I opened it to Visual Studio.
If you right click the solution, there should be an option for it, I believe.
Oh, there should be.
That's the project, the solution on top, at top.
Oh, I didn't even know that.
I guess it's not there.
Well, probably because he already has it enabled
sure.
for his solution. Maybe that's why.
Actually, I'm using somebody else's laptop
Oh,
today,
okay.
so it just happened to install here. I was hopeful that we're gonna get this working. But I think the only issue is like you might need like F# 3.0. So I'm using here Visual Studio 2013 Express Web, and you need the NuGet package manager installed, which you can do through the
Yeah, it's in the story now.
okay. So
So then
So, anyone? Any successful install? No.
take a while to download the nugget.
It would be really, really dismantled if no one can run it. Would anyone want me to look at their computer and start it?
Yeah, this is mine.
Yeah. 2012 might actually go, because I think I did working on my machine.
I'm actually pretty good with the NuGet package manager.
You won't have a never heard that before.
I think you're good, yeah.
All right, I have no idea what I'm supposed to do. Okay.
I thought you're gonna be
I
presenting.
think the
I thought you were gonna be presenting.
So?
You're gonna be there? That's fine. Hey, you want me to
Oh,
see?
no, I've got the introduction.
Let me get out of your way so you're not like awkwardly hovering over my
So on
shoulder.
this machine, we found out that NuGet
Oh, the source
package
code
manager was
I wanna
outdated.
get the source
Okay,
code.
so
We're able to
make sure you update your new kit.
Yeah.
that might help. Or might help, but I hope it will. That's a problem.
Hey, Anton, do you need
Yes.
the library for?
I think NuGet should fetch everything.
Doesn't get the IntelliFactory.
I don't even know if there even is NuGet for 2010.
Wait,
Yeah, it seems that they got the
The project is 2012.
Yeah, there is NuGet for
It does.
Okay.
But there is
The others?
What
Yeah.
Visual Studio do we use?
Now try to restart on this.
Okay.
See if you can.
I cannot, yeah,
All right.
I did not use it.
Oh,
Again, I'm for
Well, I
sure.
can really tell you because
All right.
it's different. So,
You might be out of luck with 2010.
You
said 2012.
Did you say
Yeah, I use it. But it's probably different.
Wait, that was the first one.
how you install
I see you
projects.
yesterday and
Yeah.
NuGet
come
package.
I
there.
couldn't make it. I had to choose between two
Hopefully it
of
works
them,
the
so
same.
I'll choose this one. I heard it was good, right?
Anyone else?
Packages of versions.
Did you like it?
Yeah, it was okay.
Ask to restore.
What did you do? What did I do?
It was actually HDFS, so file computer system.
It's in the,
Yeah, there was some. Anyway, it was a neat presentation. Nothing they're gonna use. Good stuff to know.
For you yet?
Security key for the Wi-Fi?
Yeah, it works.
Key.
One machine works.
How are we connecting this to the Wi-Fi?
It's right there. The Wi-Fi info is on the blackboard up front. It's F# at Beeline. F# meetup is the SSW.
You might want to
It's
use
on
another
Apple.
voice.
Oh, yeah, sure.
Okay.
One more machine.
One there.
Yeah, one there.
Yeah.
Let's try to cover.
Yeah, let's make the rounds. Yeah. Yeah.
Parallel. Parallel or
That's for people that don't work here to connect to the Wi-Fi.
My laptop is having a very bad week.
Oh.
It's F#. So it's the actual sharp sign, not the. Yeah, so capital F. And then sharp sign. Add. Add line. Beeline.
But I know how to install a NuGet package.
Okay.
I've got that much.
Do you use that?
I work at a game studio out in Fairfax, and we do a lot of back-end server stuff in that.
Oh,
Okay,
okay.
Does this?
Sorry.
I think I got it.
Okay.
Does this look? Does this have options?
Excellent.
Password.
So imagine you get
Oh, that's the code in there. There's a F#, add the line.
online,
Thank you.
search online.
Are you using Xamarin?
Yeah. Well, I forgot to, my battery died on my the PC, so I put it on my Mac for now.
So you had success.
But I don't know how to use my Xamarin yet. But I'm playing with the Xamarin for iOS,
Just going to
small
bring it in.
iOS app, just for proof of concept for
Right.
one of the projects. So
That works
playing with
fine.
that for now. Yeah.
Super.
Any success out of that?
I think it's working.
Oh,
Maybe.
just slowly.
Yeah.
Yeah, it takes a while.
You should just see
What are we installing there?
That's
WebSharper. By new get.
This is all WebSharper. Read the second person.
Different versions.
Oh, you want previous? So, he's gonna, when he's gonna install, so. Things may be different. Correct.
It's still there?
Huh?
That's still working there?
All right, we got two people. Two people. Three.
Oh,
I don't know, we
that's
can probably got two. So if everyone updates their, you get.
What did you do?
wait.
Now.
Part of this?
Everybody, all right, cool, great.
Why did you leave?
Yes, sir.
That was quick.
They want me so bad. What can I say?
Oh.
You can download.
How is the Eunice is gonna look it out?
That's good.
What are you doing?
I don't know, but definitely I will do better.
You double click it and it installs.
Okay.
But you should.
Oh, okay.
You might have
Not
to.
a side by side install
Yeah.
tomorrow. And so, you know, if you have a really strict production requirement to be using 4.0 for the stuff you build, it will get overwritten.
If you don't mind, you can you unpack it here? Open it in your Visual Studio.
Yeah.
Is there a way to set up, we found the package, but it requires 4.5?
Yeah, you have to use Visual 2012. You have, so the only way to get for you is get Visual Studio
Okay, I think
2012
We're just
Express.
missing a machine in this corner. I can. Oh no, never mind. My laptop has a power jack problem, so that's not the most urgent one. It's okay. Now that some people at least have.
Steve, just follow along, and you just try this stuff out later.
So let's have a look at the code. Please, apologies everyone for it's much more complicated than I thought it would be, but if you have a neighbor that has it installed, please share. Yeah, so you can follow. So the Void.fs file is the most interesting one that actually has the model, and there are several rules that make these little things flock together. And these rules correspond to functions. And the functions compute, let me look at a simple one. For example, keep away rule. Let me zoom here. Whoops, interesting. So there are really 3 rules, but you can add more rules, of course, to make them do something different. Voids try to keep away from objects, including other voids, because otherwise they might collide. So when they are close to each other, they try to stay away from each other. They try to match the velocity of the surrounding voids, and velocity is a vector, so that actually means not only the speed they match, but they try to fly in the same direction. So that's that rule right here. And I think mouse care rule is the one I added to the model to make it run away from the mouse. So that was not really necessary for voids. Center of mass rule is the 3rd rule that is necessary. They try to congregate. So the perceived center of mass is calculated by looking at the neighborhood. They look at the birds around them, and they average their positions. So how does it actually work? Is the F# syntax confusing, or should I go into that? For example, let's take a rule like center of mass rule. Yeah. Sequence is your I-enumerable, which you might know. This is a sequence comprehension expression in F#. So we are looking at every void within a certain distance of the current void's position. And we are taking the position of that. So this whole expression here is a sequence of positions of neighboring voids. And then we take the average of that using a function I just wrote up that takes an average of sequence of vectors. Then this funny operator I created as well. It just takes the difference of two vectors. It's a vector difference. So we take the difference between the perceived center and the current void position. We multiply it by a factor. And that's the output of this function, which gets added to the velocity. We can look at that below. Here is a step of the simulation that happens on every every tick. It actually gives us delta time. It's how much time was passed from the last step around. Why do I need to do that? Just so that I can measure things in terms of actual seconds, not how fast or slow your computer runs. So here what we do, we change the current velocity of the void by adding all these vectors that different rules give. We make sure it's dampened. It means it's not greater than a certain amount, so they don't fly out too far. And then we move the void by the seconds multiplied by velocity. Yeah. So the only strange, it looks like F# code. The only strange thing about it is that all of this is cross-compiled to JavaScript. So that is reassuring to know that things like custom operators do work. If you haven't already, do try tweaking the coefficients, even if you have the working style. Any questions so far? How are we doing? Is it?
I see a bunch of like
Yeah.
0.025, 0.05. What is 1?
What is 1?
1 represent?
Yeah, I actually renormalized the coordinates, and if you forgive me, I might use the old-fashioned method of drawing the board.
Yep, there's erasers on the bottom.
No.
Oh, yeah. Actually, I do agree. It's hard to know what does 1 represent, so I find it helpful to renormalize coordinates to actually represent something. In my case, I renormalize coordinates like that, x and y. So here's our screen, here's the square we see, here's the canvas. And it has a certain pixel width and height. But the logical coordinates, 0, 0 is the origin, x goes to 1, 0, and minus 1, 0, and y goes like that. And that would be 0 minus 1.
So basically you're scaling it in terms of percentages, and except instead of using 100%, you just use 1.
Yes.
Okay.
So 1 is half of the visible space. And actually, if you look at the Solution Explorer here, we can jump to the extensions FS, which is a few methods that I wrote that were missing from the, I don't know what that one is, that were missing from the standard library to help with that. There's an animate method. This is where renormalization happens. So that's not really very interesting. But what is interesting though is that if you look at the API of the canvas that we use to draw in HTML5, the API is imperative. So you take an object that has some methods like move to, line to, or clear rect, or draw rect, or fill. And you use mutable state to operate on this object to create shapes. I find it a little bit distasteful, but thankfully in F# we can turn that around. So How? And this is what I've done in the shapes model. To actually do a drawing instead of, I'm basically encapsulating that in the pure type. A shape is a function that takes, here it is type t, or shapes.t, is a function that takes a rendering context and does something to it. And by itself, it is a pure value until you apply it. It's like an I/O in Haskell. It describes side effects, but it's not itself side effecting. And then once we have that, we can write a few combinators on it. So this model proceeds to do that. Draw just applies a shape to a context. T is of type shape.t. It was inferred for us because I actually like the sharp records a lot for things like type inference inside model implementations. I don't have to spell out that T is a T. And save restore makes sure that whatever modifications we've done to the context are properly scoped when we're drawing. So if we change the color, for example, it doesn't leak to the next thing that's drawn. Define just defines in the helper function. So let's look at some scale combinator, for example. Yeah. Scale is of type vector to D, to T, to shape, to shape. Ah, that's not very visible there, is it? Let me scale it. Yeah. So what it does is it takes a shape and produces another shape that is rescaled. And we can use that by implementing this as a delayed effect on the context. We don't really have, but it will come in the function. Is everyone familiar with this funny pipe combinator right here?
Backward pipe.
Yeah, backward pipe. I didn't have to use that. I could have written, oops.
Parentheses.
I could have written parentheses, yeah. Yeah, that's the exact same thing. In there. So it just takes a context, it uses the scale method to make the current coordinates rescale, and then it draws them. And we have a bunch of other methods. Like here's a triangle method that I was lazy to compute the coordinates of equilateral triangle, so I just did it with angles and stuff like that. But what it does by default is, I will draw here, if you excuse me once again. It takes a unit circle and it draws this thing. That's the shape of the triangle. And if you want, void will be actually a little triangle that's a little bit elongated and it's sitting somewhere. So how do we go from one to another? Well, using combinators, we first scale the big triangle so it becomes little, and we use different factor for y so that it becomes elongated. Then we rotate it to where the void is facing. And then we translate it so that it actually gets to the current position. Let's look at that in code. So we go back to voids. Yeah, void shape is a function. Let me zoom in on that again. That takes a void and produces a shape. Pure function, again. It deals with side effects, but they're delayed. Zoom out here. So how do we implement it? We take the triangle, fill, another combinator that just gives it a color. Fill it. We scale it by a factor. There's the x factor and y factor. Together they are a record of type vec 2D. Align is sort of like rotate, but instead of taking an angle, it takes a vector and then computes the angle. So if this void was going there, then we can compute this angle alpha by using the atangent function. So just taking kind of simple. And the void set is just using a union of all the void shapes. That's much that. So where does actual drawing happens? Actual drawings happen in the animate function. Initial voids creates 50 voids at random positions, and then we use canvas animate, On every tick, we do a step, which recomputes the positions, and the draw, which draws in voids. Draw is actually using shape draw to take the shape of all voids and put it in the context. This one is imperative here. Yeah. And on the mouse move, we set another state parameter, which is the current mouse position that we use to calculate the mouse scale rule. Yeah. So, how are we doing so far? Any questions? What should we look at more?
What do those parentheses after draw mean? Like, are
Yeah. Here.
yeah.
Here, draw is a function of type unit, so it's an imperative. It's like system.action. And parentheses means call it or invoke it. I could have written them with a space, I could have written them without a space. I'm not sure that WebSharper is decided on what's the proper way to do that.
So that's a way to call a function that doesn't have any parameters?
Yeah. That is, but if you want to be very technical one, this parentheses together is a value of type unit. So f is a function of type unit to unit, and application, you can compute the type of application by taking the type of the function and type of the argument and cancelling out the argument, and you get that. So it's a type unit. So unit is really nothing. It's null at the runtime, but it helps to keep the type system consistent. So it could have been if there was with function of type int the unit, then the application would have to supply an int like 3. Anything else? Okay. Shall we look at the two-dimensional vectors quickly? It's a simple model I hacked up to a vector just as a record of 2 points, x and y. Here I use auto open on this model so that I don't have to qualify the vector D type with a dot just for convenience. It has 0 of this. A vector norm defined as the square root of the squares of x and y. Not very meaningful by itself, but it's useful to normalize the vector if you want to. I just use it to dampen. It's helpful to compute distances and it's helpful to normalize the vector, just basic geometry stuff. So if you have a vector, it can be conceptualized as something that here's x, y. There's this thing pointing from origin there. So it has a certain length. And then sometimes we want to change that length, but keep the direction. So how do we do that? We just do scalar multiplication by 1 over the vector norm that gives us the unit vector. Well, in this case, unit vector is on the circle. So it wasn't a very good example. Unit vector in the same direction and multiplied by a different length, and we get any kind of vector in the same direction. Average, just for some speed, call it up as an imperative loop. Why not? We can do that. Sum of vectors, same as average, just doesn't divide in the end. And here are the funny operators. And since I'm auto-opening this model in F#, these operators become also available everywhere. F# has very simple rules for operating operator precedence. That basically, operator precedence is defined by the first character in the operator. So if it starts with a plus, it behaves like a plus. So if you define plus hat, and you define multiply hat, and then you have an expression that contains both, then the precedence rules will be like multiplication and addition. So that's kind of helpful. So I define a plus hat to add, minus hat to subtract the vectors. Point-wise, I mean, there's nothing really very interesting. And a scalar multiplication by constant. This star hat k is actually a float, and v is vector 2D, and the type of the whole thing is what? Can somebody give me the type of star hat? Did I just lose it?
Vector 2D. Would it be vector 2D, the return type?
Oh, what I'm actually asking is I'm asking the type of something that is defined as star head. For example, I can give it a name. So here I do another binding. I can give it a human readable name, right? Star head. And define it to be equal to that thing by itself. Yeah? In Sharp you can do that. What do you think is the type of star head? Well, yeah. And you read it basically as a binary function on vectors. But
is there a particular reason you decided to define new operators as opposed to just going with like .NET operator overloading and using plus?
Yes. First of all, I prefer it that way, and second, there might be some issues with how they translate to JavaScript right now. I didn't want to get into that, so it's right now it was simpler to just do that. But we are working on that. We're trying to make the .NET operator overloads work. Yeah. And another cool feature of WebSharper that I just discovered myself last month is that you don't have to specify all static members together. You can spread them out. So here I am extending vector 2D with another static member called distance. And here I'm using the hat operator defined on the minus hat on the model. So the distance is the norm of the difference between two vectors. Yeah. It compiles just like a regular static method, so you just have a static method on vector 2D. So we looked at vectors, we looked at shapes. Extensions are not really interesting. We looked at different rules and voids. Then comes some boilerplate. Client model is the main model that your application gets started. So here we just, what happens here is this div actually is an HTML-like combinator, so we can do something funny like we can add a button. Oops. And so this HTML just gets generated by JavaScript and put together in a DOM graph. I'm splicing here a canvas. Here I'm just doing that with the button. Here's the button, if you can see it. If we wanted this button to do something, we use a little strange syntax, but bear with me. Yeah, I can make this button do something like that. Compile this. So this is just part of WebSharper HTML library, which maybe is not the best designed library in the world, but it works for the time being. Don't develop something better. So here we go, and when I click it, whoops, you can tell I'm using somebody else's laptop. All the keys there. Yeah, you can see the console logging in the browser console. But you can make it do it something to the voids as well, of course. Doesn't have to be that. All right. So this just gets called, and mainfs is the server-side boilerplate. I mean, it's not very relevant for this application, but if you define multi-page applications with complex dependencies, then it sometimes helps. We are not really going to dive very deeply into that. Okay. So, shall we try to do something Have any one of you tweaked the model, got something interesting results, like running away from each other? Send a pull request to the GitHub.
I have a question. It seems that everything boiled down to JavaScript, or actually when you create some DOM element, it creates HTML for you. The HTML created from the JavaScript that you compile using F#, is that correct?
Can I get the question again?
When I mean, like
every
you
void
the
corresponds
bottom,
to
the
normal?
OK button, yeah. Is that
Oh, the OK
yeah,
button.
it's created from the JavaScript that actually you compile using F#, is that correct?
Yes.
So like
yes.
NS layer and direction.
Yes, another layer from direction. So if you look at the HTML of the page, it's not there, but it's in the JavaScript.
Okay.
There are similar combinators for actually generating on the server-side HTML that you can see on the page. Sometimes that's useful.
Can we actually see the source of the page's source, just to see the JavaScript?
Sure.
And I see that actually there are some jQuery.
It looks like assembly code, sort
Yeah.
of, so it doesn't look very nice. But we can look at that anyway.
Firefox.
I think I lost my place here. Yeah,
No,
you're right.
Firefox.
I'm in Firefox. I think this is the one.
So dynamically create for you the JavaScript file here. Okay.
So we've been running in like debug mode. So some spacing is here, and identifiers are longer than they could be in release mode. Just yeah, it looks like assembly code. We don't really read that much.
Can you zoom in a little bit?
Anymore.
Just
Yeah, I can zoom.
Oh, yes, it works.
Plus hat is here, our operator, but it actually spelled out and like that and stuff. We recently have a new mathematician on our team that tries to help me like fix some of these things. So we've been working on the optimizer there. And the good thing about it is if you really treat JavaScript as an assembly language, if you don't care how it looks like, and you don't depend on it, then somebody else comes up with a better optimizer, you just run it, the application is still okay, just it's now smaller, faster, things like that. So we came up with a few optimizations that we're going to try out in the next release, if we can remove some of the things.
How do you debug this?
Huh?
How do you debug
You don't.
right.
Actually, the only thoughts I had for debugging, that how we could envision debugging in this crazy world is by instrumentation. So instead of making every function correspond directly to JavaScript function, you could make in debug mode. You could generate different kind of code that computes stack traces in .NET terms and stuff like that, and actually gives you a debugger application in JavaScript instead of the JavaScript debugger. So at least that sounds like it's more feasible than trying to make it look like that.
TypeScript and all the other languages, they have some kind of mapping, right, where you can...
TypeScript maps a lot more directly. You can predict what JavaScript will come out of it. Of course, what you cannot predict with TypeScript is whether your program is going to crash with type error or not. But that's
I think even in a there was a C++ one which provided a debugging symbol mapping or something, where you can...
yeah, we are looking into trying that, but I haven't actually gotten to try it yet. There is this thing called source maps.
Yeah.
That you can actually use the JavaScript debugger, but it instructs it to look for your source elsewhere. I haven't experimented with that yet to see how well it would work, but I actually have some difficulty even debugging just a plain F# code, just in .NET, not to speak of. Just because of tail calls, because if you ever had an application that uses a lot of async in F#, async is an abstraction for asynchronous programming that's implemented using like basically control flow inversion, so it passes callbacks around, and you look at the stack traces, you have no clue. Because you basically lost the debugger. The whole idea of a debugger makes very strong assumptions on how your code should be organized. Like it doesn't know about tail calls and stuff like that. I think even for pure F#, you would want some instrumentation. So you want async with some extra support that recomputes the stack trace to actually make it look like you can know what's going on. So instead, we just use tests. We use like algebraic design, and we say, okay, this is a monoid. It should have these rules, and try to keep things simple, which helps a lot with F#. So
Given that this is pretty far removed from human readable JavaScript, what kind of ability do you have to either call into third-party JavaScript libraries like say 3.js or write your own JavaScript that calls into something generated from the F#?
It actually generates a surface that you can call into from JavaScript, and with the latest release we're experimenting with generating TypeScript. Description of that so people can call it from TypeScript as well. It was requested by some clients. As to calling JavaScript code, what we try to provide an F#-like interface, because JavaScript doesn't have types, right? So we try to provide F#-like interface, and very recently we've been looking into compiling TypeScript definitions again, because there's just so many of them. But we have a few libraries. If you look at just the open source ones, if you look at GitHub for my company, you can see jQuery mobile, D3 bindings, Bing, O3D, jQuery UI, globalization, Google Maps, that have its typed bindings that you can use NuGet to download the library, and it will look like a WebSharper library. If you want to make them, there's WebSharper documentation how to do that. Calling JavaScript is very easy. It doesn't involve any overhead, so we do it all the time, pretty much. The only problem with that is if your annotated type is wrong, if it doesn't describe the JavaScript function. For example, you created a binding that said that this function takes a number and returns a number, but somebody who wrote that function made a mistake and their documentation does not describe the library, then you're in trouble. So what we've been also looking at is having an option to generate contracts for FFI, for foreign calls like that. Contracts would do runtime checks on that. So if you have a problem, of course you don't want to run contract checks on production, but if you have a problem, you put the switch and then contracts check which contracts have been broken, and it says, okay, that function has not been bound correctly. So we're looking into that. That will help in some scenarios, I guess.
Ultimately, you're calling JavaScript, you're dealing with not a type system. So
yeah. Well, actually, you can approximate it quite well, but up to a point.
So how difficult would it be with the code as it is right now to add in an obstacle avoidance for the voids?
Very easy. I hope somebody would already be done with that, but we can try together.
Okay.
So all we need for that, we need to introduce the concept of the obstacle to the state, which probably we just need a position, for example. For starters, it will be just a point, right? And then we need to introduce a new rule that will make them steer away from it. Yeah, let's do that. So here are voids. Let's look at the type that keeps the state of the model. Here's the void state type. Zoom in. It keeps the mouse coordinate and the void. Let's extend it. So first I can copy the mouse curl, let's say obstacle. Oops. On my, I'm not using my own machine and I have caps lock command. Doesn't help. So here instead of a mouse, we are using the obstacle position. And you would surely notice that these functions duplicate code. So what do we do instead? Make another function. And then just Then we need to add the role to the sum of what's the changes? Yeah. And we still have not set up our obstacle, so thankfully, yeah, we have an error for that. So let's put it at, I don't know. Let's put it in this quadrant. Let's see what happens. Let's try to push them towards it. They do not want to go there.
There we go.
Oh, there was another rule I added to make them like to congregate in the origin, because otherwise sometimes they would fly out of the screen. So now they really like the origin and they don't like that corner.
Can you draw the grid at least, like, you know, on the surface also as a background kind of thing, so that we know where the middle kind of thing is? Just for the hell of it.
I think you could, yeah. We can try just do something quick and dirty. Here's the animate function. I wrote this one, canvas.animate. It actually clears the screen on every tick. This is why we have movement split. So that means that if we want a grid, we have to draw it on every row. So I don't think I have a line shape yet. Shall we do that?
Yeah.
Line shape. Let's look at the triangle shape, which is awful, but it's a place to start. Let's do a line shape.
Just the X and the Y.
To the 2 points next to D. Yeah. Okay, let me remove the computations that were trying to compute the coordinates of the triangle, no longer relevant. So we move to the first point. And we put the line to the second point. I'm not doing very well with this keyboard, am I? All right. I think I need to stroke. This is not a very tight binding.
Do you need to set that before you actually draw the line?
I have no idea. Let's try. Let's try this.
You can do it after.
You can do it after?
Yeah, I don't know about what you're generating, but with HTML5 you can do it after.
Yeah, this imperative fragment here should be pretty much like a mock-up of a JavaScript you would write. So does that look okay now?
You want to style it before you stroke. So
Okay.
you had it right the first time.
Right. Okay. Yeah. The only thing that I think will be annoying is the line might be scaled to be very thick, but we'll see. We'll see if that's the case. Anyway, voids. Draw. Oh, we can just even edit here. Alright, so we need 0 minus 1. Two. Okay, we need to yield another funny syntax for creating sequences. So yield takes an element and pushes, like, makes it available in the sequence, and yield bang takes a sequence of elements, which we could have also written once since we are using the syntax. Anyway, okay, let me see here. Okay, another funny thing about F#. Number literals are not overloaded, so instant floats are different. So it didn't like the ins I wrote because it accepts floats. So the float number literals are with a dot at the end. Okay? Could have written that. And we don't need that. So there's a vertical line, and what was there before? No. Okay, let's try it. I don't have a good feeling about it, but let's see. Yeah, that's the line. Okay, any ideas how to make it a hairline that doesn't scale with the context? Somebody knows Canvas? We can, of course, apply it before I change the coordinates.
Did you draw 2 lines or just
one line.
It's just one, it's just very thick. Because I rescaled the coordinates, it's width of 1, it got
Okay.
very
Alright.
thick.
Not a hairline. You have to draw 2 of them. This one you can scale it down back to 1.
Oh, I can rescale it, you're right.
So this one's fine. This is your horizontal line. I mean
Vertical.
vertical line. Yes.
Yeah.
Then you just need a horizontal line, and that's it.
We can do the horizontal one, of course. But it's still gonna be thick, I'm afraid. So you would just do this, yeah?
Let's see.
1 and 0.
1 and 0, yeah.
Oh boy.
How about we draw the obstacle on top of that also?
We could definitely draw an obstacle. We could put something there. Very thick lines, huh?
A little.
So we could fix that by altering the
ratio.
Altering the shape type to do something that applied before or after rescaling, maybe. I'm not sure I have a very good solution right now for my current state of the brain, so let's skip that. Yeah, well, the drawing is one thing, but the fun thing to play with this model, you can flip the sign, for example, on the mouse rule, and then it will try to congregate to the mouse instead, or you can make them. Well, you can tweak the coefficients. You can really play with it. You can also design UI to tweak the coefficients dynamically, so you can have a slider that you slide on the coefficients. It's fun to play. So this was using Canvas. There are a few other options available in the browser you can draw with. Unfortunately, I can show you right now an active example right here. But you could use something called SVG and their libraries that maybe even draw to Canvas under the hood. But what they do provide is a little bit of a nicer API. So here we are dealing with shapes, and the shapes, if I wanted to make the shape clickable, I would be out of luck. What I actually did, I made the canvas clickable, so I have mouse coordinates, but that was a quick fix. Making shapes clickable would involve more. I would have to map the mouse coordinates to the actual shape. So it's work that you might not want to do if you're just trying to make a visualization for a client. So we found on one of the projects we've been working on, we found the Raphael JS library pretty helpful. So we made a binding in WebSharper. What that thing does is you work with they define their own concept of shapes, you create them, and they have events like DOM elements. You can make them clickable and things like that.
I actually made a desktop application with Canvas. So everything you do on a desktop, you will be able to do on the Canvas. And basically, I had to define my grid and keep track of every one of my grid, and then draw icons on it, on grids. And then you can drag the icons around, drop them anywhere, or on top of other icons. I just had to keep track of everything. But it was with Canvas, not with SVG.
Yeah, you can definitely do that with Canvas too.
What kind of
just you need to program it.
Right. What kind of products do you guys develop with this API?
Pretty much everything that we can get your hands on. So just internal projects. One fun project to work on with the client was the University of Nebraska Medical Center. So what they wanted to do, they had some biological data, and they wanted to visualize it online as a website. So there wasn't really as much biology in it as I hoped for to learn. But we did bacteria genomes, and we made a little chart that allowed researchers to scroll through the genome sequence, see the different proteins, and color code them in certain ways to try to see interactions, and connect it to the online databases of information on those proteins. So you could kind of explore and click around and find out which protein is responsible for what. I think what the researchers were doing there, they were trying to find how to make the Staphylococcus bacteria, how to treat it more effectively. So different strains of this bacteria, how to develop antidotes. But that was one project that was fun. Okay, everyone, I apologize that this setup was not quite successful. Yeah.
Okay, so I saw that you using some jQuery library. Everything was as a.
Oh yeah, jQuery is.
Are you be able to integrate jQuery using from F#?
Well, there's this little. Let me perhaps show an example.
You just have a binding in this?
Huh?
You have a binding to jQuery in the
We have a binding to jQuery in WebSharper that's part of the standard library right now. We'll try to factor it out later, but right now it's just there. But how to create a binding, there's a few mechanisms. Like one of the simplest ones is I can write a function. I can give it a type. And the implementation doesn't matter because it's ignored. And I write that. Right?
That's it.
So you created a binding for something. Of course, console is already present. We also have a framework to declare dependencies in the JavaScript file so that they will be loaded if somebody uses that. So that's how jQuery works. But it should be in the manual, but I won't go into that. Here we can use that instead. Use load. However, in practice, we found that writing inlines for everything is sometimes not the most efficient way to work. So we also have this a little DSL in F# where you can construct this kind of bindings. And why DSL in F#? Because sometimes JavaScript libraries are very repetitive. You look at the documentation, it looks like they're generated by some tool because everything is. They have a pattern, and every library has their own pattern. For example, here's a pattern for how we bind properties and classes and something like that. So with the DSL in F#, you can abstract that pattern. You can write a little function that says create class, given the list of properties, and you can use that. And then it generates the metadata for WebSharper to work with that. We call it interface generator. And most of our bigger extensions, like extensions to XGS, SensuTouch, they use that instead of writing inlines manually. Actually, they've even been trying to parse the documentation for this library sometimes. But we are hoping TypeScript definition files will be kept up by the community, so we'll try to parse those instead to make that also a source of typed information for WebSharper. Does that answer the question?
So you guys prefer working with F# rather than direct
Oh,
JavaScript?
absolutely, yeah. We are incapable of writing JavaScript correctly. It's a legacy of being an F# shop, I guess. We're just very used to F#. We like it a lot, and we develop everything in it, including this web stuff. So the latest projects, I'm not going to show where, like a lot of potential in them. Hopefully it will just work on a little preview here. We've been trying to make this
We can't see your password.
oh, really?
Change it when you get home.
Wait, a new account or something. So anyway, we've been trying to make a little IDE that would allow you to edit F# and WebSharper stuff. At first we thought that we'll just make it online. But lately we realized that it would also be helpful to have as an option an offline mode, because so we've been working on an offline version as well. Oh, please log me in. I apologize for this. I think it's not optimized for this reduced resolution that I'm having on this machine. So this application, the front end is written in XGS using WebSharper bindings, and you have a little IDE-like thing.
Thanks. Even the syntax highlighting and everything.
Syntax highlighting, some code completion. We're trying to get it on par with at least like the mono tools for WebSharper right now. So yeah, the complex part is the sandboxing, because we're trying to run this
on the web environment. You don't want the server to be
right.
Yeah.
So the hard part is sandboxing F#. We had to modify the actual compiler. That was kind of painful.
Mm.
So trying to work around right now to find a cheap way to make it safe sandboxes for everyone without using an actual VM for everyone. So we might end up even using like Linux containers or something like that to host F#1. Let me start a simple script here. But we also realized we can provide a local backend for it, so that if you are working at home on your desktop machine, you can install the local backend, which will give you more speed because you're using your own CPU without the indirection of the cloud. But if you're on the go, you see you're on the same files because they're synced to the cloud. So if you're on a different laptop like today, you'll be able to still have your files there.
You have the version control integrated in here also?
We are using JIT, but again, like this sandboxing is not really convincing yet. But let me just run this in FSI there. Oh. So it's Sharp Interactive running in the cloud, and yeah, giving us output here. So there's a couple of directions you can take from here. I personally hope, I'm not sure we'll actually find time for this, but maybe somebody else will do it one day. But I hope F# will become a better language for doing data analysis, because I have a little bit of a background in statistics, and I tried to play with R before and things like that. Those things have awesome libraries for pretty much everything you need. but the language itself is the most, like, it breaks every single rule of language design, like dynamic binding together with static binding together with like whatnot. So I think F# would be capable of being a more productive language for this kind of environment, but unfortunately the libraries still yet have to be written. So I know Matthias Brandewinder is working on some type provider to integrate with R. So maybe
yeah, he's working on it.
might be a pragmatic choice for now, but in the bright future I would hope that languages for statistics would be better.
Have you tried using R with F#?
Uh,
Just for visualization?
Not in a long time. There was one project, maybe like 3 years ago, that I tried to do that. And it didn't work well. It was before type providers and all that.
That didn't work very well.
It worked, but it's, again, it's one of those things where marshalling takes a lot of effort to, it has a runtime cost, and it also is difficult to implement correctly. So you have to switch context between F# and R, F# and R, and that's not very nice. If something is very simple, then yes, if you just have, here's my data in F#, feed it to R and run this function and give me the graph, that's okay, that can be done. But if you need to code something in F# together, then it's not very nice. I think this is where this type provider, if it does work out, it would help a lot with that. But ideally, I would hope that statistical libraries could be ported to like .NET or something like that, and we would just use them. Because F# is just a better design language, in my opinion. Opinion is different. So yeah, this was Cloud Sharper.
Well, there is a project out there, actually Thomas wrote a fun script, use a type provider to do a subset, which we're doing here, using, creating JavaScript on the fly using type providers, right?
Yeah, I think what they're doing is what we also try to copy that now, because that's actually a very good idea. It's a sound idea. Have a type provider for TypeScript. And I had a working prototype, but for the old TypeScript updated, I was working on this instead.
Oh yeah?
Now I need to upgrade to TypeScript 0.9 because all the bindings are already there, so I'm a little bit lagging behind. That's one of the disadvantages and advantages of working in a small company is that you have to work on everything. So you get all sorts of experience, but the downside is you have to work on everything, so it's like you can delegate much if you have like 3 developers. You have to, yeah. Well, thank you all.
So, last question. So,
Sorry.
what made you, the decision to use F# as tool to develop this project? Is because the functional natural JavaScript can be like, can be interpreted as sort of functional programming as well as JavaScript.
You can certainly develop JavaScript functionally, and you can develop big code bases for that. People are doing that. I just think that F# makes especially our team more productive, because we have a lot of experience with it, first of all, but also I think just because, well, even looking at that, at our code here, right? If you look at our code, if you look at vectors2D, for example, I just wrote this.
Mm-hmm.
So what do we get from that? We get the working library as a model, but we also get an interface for it automatically. You can even generate it, like documentation from it and stuff like that. And even in C# it's the same, but in C# I had to spell out more times. Here I don't even need to do that. So it's really respectful of your time as a programmer because it doesn't throw away that information, it keeps that. In JavaScript, you write this, and then you still have on the to-do, write the documentation, how to use it, write an API, then test it, make sure it's consistent. Oh, it's inconsistent, your API doesn't match the library. All sorts of errors, especially if you're not experienced. I'm sure experienced people solve this somehow, but when I tried writing JavaScript, I think that this is how WebSharper started. I was assigned to write some JavaScript. I totally failed. I was running into things like it doesn't check even arity of functions, so you give wrong number of arguments to function, runtime error, compile checks. And didn't like that. My previous language was Haskell, so I was really, this is not, this is awful.
Right.
Yeah.
Do you think that?
I think the future of JavaScript really is the assembly language. Of course, people will continue using it as a language too, no question about that. But to me, it seems like it's like there's this another compiler, Mscripton, that compiles C, C++ code via LLVM to JavaScript and can run games and things like that with high precision, high fidelity compiler. So WebSharper is just compiles a subset. And if you run right now, if you run it into corner cases, you're out of luck. We're trying to circumvent that, but Mscript and some other projects, they just use JavaScript as assembly language, and they make the applications portable everywhere. And that I think is really nice, because JavaScript, with all its flaws, it's accepted by, it's installed everywhere.
Yeah.
So
Yeah, we're stuck with it. We're stuck with it.
we stuck with it,
Oh,
yeah.
and now
We stuck
more than
with it.
ever.
Exactly.
Do you follow Scott Hanselman?
I read his stuff sometimes, I'm not sure I.
He wrote a blog that JavaScript is the assembly language of the web.
Yeah, I mean, that's, the idea is obviously floating around.
Yeah.
It's the future. Actually, there's another cool project Mozilla team is working on called ASMGS. So what they're doing there, they are kind of giving you yet another language, even closer to assembly. Like you wouldn't want to write that one by hand at all, because it's just awful. But this language is much more restrictive than JavaScript, but they can compile it much better. So they can compile it to the same speed as Java, basically, or C#. But currently it's lacking a few things, but it's been used to speed up compilers like Emscripten primarily. So we're also looking into maybe using that one, because it's interesting. So for us, so ASMGS, it looks like JavaScript, it has JavaScript syntax, but it has nothing to do with JavaScript because it's not parsed as JavaScript. But if it's parsed as JavaScript, it still executes correctly. But a Mozilla browser, modern, like the nightly Firefox, when it sees ASMGS program, it will analyze it using different rules first, try, and if it succeeds, it will compile it to fast native code assembly. So there will be no, it will know numbers, it will distinguish integers and floats for sure, and things like that. So that's interesting. The current problem with ASMGS is that it doesn't work very well with pointers to JavaScript objects. And actually for Emscripten, no problem, because Emscripten doesn't actually use pointers to JavaScript objects. They don't even have, they don't use the JavaScript heap. They don't use heap at all, because applications are in C++, it's manual memory management. But for us, it is a problem, and also the cost of calling into ASMGS and back is prohibitive. So for an application that jumps back and forth, it's going to be a problem. So what I was thinking we can try to make another notation, like an attribute, that you can say, here's the module, use ASMGS here. And the programmer has control, and you write F# code with some restrictions, and we try to compile it. If we fail, we tell you what failed. If we succeed, we compile it to ASMGS, and you get like a numeric kernel you can write in F# to run much faster. Yeah, so there's that. Thank you all. Yeah, thank you.
Ryan. All right, so don't go away. There's some raffles now before to go. Thank you. The speaker.
Do you want to just finish with the next, talk about the next few sessions?
Yeah, we're going to pick it up. All right. All right. You lose me? No. All right. So I don't know for who came later. So next month we have another talk, the 22nd November. It will be host actually a couple of blocks far from here, 15th Street. It's 1776. It's a startup kind of environment, really cool place. I've been there. And Thomas Peticiak is coming for the talk. He's going to talk about the typewriter. So it's going to be pretty cool. And yeah, I think it's close by to a metro stop, but you want to come by car. There's car garage below the building that's going to be free after 6 o'clock. So that's and so we have a couple raffle here. Okay, I'm going to give you around the tickets. So tonight we have 2 books, of course, F# and F# Expert. You have 2 ebooks from Apples. Actually, if you going to fill down, I'm going to give you right away the code, so you're able to go home and download it right away. And we have a WebSharper license and full-site subscription. Now, Anton, I have another question for you. Very crazy talking was thinking. Do you think there is some sort of can be integrated these, JavaScript compile from F# and run it using Node.js? I mean, JavaScript is fine in the end, right?
Oh, certainly. I think you should be able to write a binding to Node.js,
right.
WebSharper, and write that and serve it. What we don't have currently is a common API that you would be able to write against. So the same thing would run on the .NET stack or Node stack.
Okay.
It should be helpful to write up if you haven't done it yet. Takes you certainly can
Yeah.
So here you're not interacting with DOM at all, right? So this looks really clean and good. So if you were interacting with DOM here, would this how different the code would look like? So is it cleaner with DOM interaction, or are there any
there's a few functional and semi-functional abstractions that we came up with over the years. Formlets, and lately another one called piglets, pluggable user interface something called piglets. Don't ask me. you should look it up online. Like my colleague Loic Denisier was working at a lot of it. So here I didn't present any of that, but you could certainly build. Sharp is nice, and you can build abstractions on top of GNOME to try to hide it. I don't think we found the ultimate abstraction yet to say like, okay, this is the best way to do it. So sometimes you still get the complexity.
Just back for that alphabet.
I'm going to upload the code in GitHub here, but whatever the code, so probably, but I'm going to stay there. And this is a promo code to get 30% discount from Apples. You want to go, and get some books, you have 30% discount, and just based on raffle here. December, actually, the 5th of December, going to be like back to back, the other talk, but there'll be the holiday in December, so I figure, and there's going to be a talk that they're going to be the MVC pattern applied to WPF using F#. And I met him in New York, and actually it's going to be interesting because he built using F# all the kind of validation for WPF using double quotes. So also there's going to be some cool introduction about some technology that, double quotes, also for myself, I think, yeah, pretty cool, but where actually real scenario are going to use it? So that's going to be very interesting. All right, so I want to put it in the ticket.
Speaker just.
You good?
Oh dear. Let's take a useful as a random number generator tonight.
All right, so we have 2019. 201, it must be in this. Oh, okay, cool. Okay, we have books, prototype, e-books. You can just go online, pick one you want to ReSharper. Oh, whenever you want. All right, ReSharper here. You want ReSharper?
Oh, I have a
oh, okay.
So,
yeah.
Okay, I have this one. Okay. That's it?
Yeah, that's it.
Nothing to say?
Yeah. You can miss a question next time. Just keep going, get the ticket.
Need more. 652025. Oh.
We're gonna grab a couple of beers, probably here in the pub if you want to join us. I don't know if you want to have time.
That's just a ReSharper license?
Yeah.
For how long?
1 year. Well, actually, yeah. Until next release.
15 seconds, man. Run.
I just think it just released the version 8. So. And it's compatible with the VS 2013. Yeah, next number?
Dude, I'll give you $20 for that.
Go ahead and choose.
Yeah, just keep going. Yeah.
652024.
Alright. I think I give you one of your colleagues. It took like probably a week. I'm gonna fill for you, send to the shop, you're gonna send an email with it. Cool. A week.
Okay.
Right? Cool. Right, congratulations.
I could use a
Right? Sure.
Even 50% help, that's hard.
Does anybody familiar with Pluralsight? No?
You need Windows 8?
Alright, what
I can help that.
I do is pretty cool online course. There are probably, right now, I want to say 400 courses. Also one is about F#. It's about probably 9 hours course. Very interesting. And you can download the slides and the code is pretty neat. Next number? Yeah.
652021.
Yes.
Yes.
2021.
Right, you have a free ebook from Apples or Pluralsight. All right. Yes, Phil, I'm going to give you the code
Okay.
right before you go away, so you can just go online. And pick it
Right.
up.
652020.
2-0 or 3-0?
020.
All right. All right. Good choice. All right. Are there two more?
652022. Six five two oh one eight.
All right. You got the ebook. Fill here, and I'm going to give you the code so you can go online and pick it up whenever you want. I mean, your choice. All right. I have to check my laptop. I'm going to give you a couple of minutes, okay? I'm going to write here. Actually, you know what? There you go. I'm going to send you right away by email, and that can be 2 seconds. Sharp here? No? Yeah, you stop reading out. I'm going to send you the email right away with the code. So. All right, well, thank you everybody to come, and I hope to see you next month. Contact provider. And again,
That one is going to be fun.